Here is another problem that involves integration by part. Now, if you look closely at this problem, you discover that this one is different from the previous one we did because the polynomial function here has a power of 2 and the other one just have no power. So this is x squared multiplying sine x. So as we have the power of 2, that means in this problem we are going to integrate twice. So the power of the polynomial function determines how many times you integrate a problem when it has to do with integration by parts. So in this particular problem, we are going to integrate twice. Now remember that this our x squared is our u because it's a polynomial function. I told you in our previous video that when you have a product of polynomial function and a trig function, the polynomial function becomes your u and the trig function becomes our dv. Now let's write down our formula for integration by part, which says that integral of u dv is equals to uv minus integral of v du. So from here, our u is equals to s squared. So our du over the x is equals to 2x. Then making our du the solution of the equation, our du will give you 2x dx. That's what our du will give us when we cross multiply, making du the solution of the equation. Now our dv is equal to sine x. Integrating both sides, our v will give us minus cos x. So how we got done it? Let's substitute it to the problem. And see, substituting it, we now have integral of u dv is equal to, our u is s squared and our v is minus cos x, minus integral of, our v is minus cos s, and our du is 2x dx. That will be 2x dx. So from here, let's use this to open the bracket. We now have our integral of u dv equal to minus s squared cos x. Now here, minus times minus is plus. So we bring out the constant out from the integral sign. We now have 2 integral of cos x dot x dx. Now, if you look at this problem, discover that we are done integrating this side, but here we still have what? Product of what? 2 functions. So we are going to integrate this part. After integrating it, we now add it to what we have as our final answer. So integrating this part, we now have I equals to integral of cos x dot x dx. So at this point, we know that our u is equals to x. So our du will now be equal to our dx. Then our dv is equal to cos x. So our integral of dv, when we integrate our dv, which is cos x, so what are we going to have with respect to x? We now have our v to be equals to what? Sine x. So let's substitute this into our formula. So that integral of u dv is equal to, our u is x and our v is sine x minus integral of our v here in this problem is sine x, and our du here is what? Dx. Our u is the s. So this is what we have. So this will give us x sine x minus, when we integrate sine x, we have minus cos x. So we now have minus into bracket minus cos x plus c. So that's what we have here. So this will now give us s sine x minus minus will give us what? Plus cos x plus c. So this is what we have in the second integral, the second integration. So having gotten this, we now add this to the former answers we got here. This is the first answer we got, minus x squared cos x. So we'll now add it to this. So that will be our integral will now be minus x squared cos x plus 2 open bracket of x sine x plus cos x plus c. Or we don't want to leave it like this, we can use this to multiply what we have. So this will now be minus x squared cos x plus 2x sine x plus 2 cos x plus integral constant c. So this is our answer. So you can see that in this problem we integrated twice. Integrated the first time, we got our answer here, but because of the product of a polynomial function and a trigonometric function, so integrate again. So whenever you solve and you have a problem like this, you have to integrate again until you have something that is as plain as this. Okay, please drop your comments. Drop your comment where you don't understand in the video. If there's any place you get lost, please ask questions where necessary so that I can break everything down to you in the way you will understand. See you in our next class. Thank you.